Next is multiple R squared and adjusted R square. What it shows is, it shows how much accuracy of our model is, how well the model fits the actual values. It shows how much variation in dependent variable can be explained by the independent variable. As we can see here, there is 99% of the model variation. It helps to make the output. So we can see 99% of the independent variable, that is height. It helps in predicting the value of weight in our model. Then there is p-value, which I already told you should be less than 0.05 in order to make it significant, and here we can see it is less than 0.05. If you want to see what is, it has been given in scientific measure. If you want to know what is the actual value of this is, you can see it is very less. It is very less than 0.05, which makes it significant here. Now what we'll do is, we'll create a regression line on the graph we have already plotted here. We'll make a line, and for that the command is AB line. Within the bracket, we can either give the model name. I have given the whole formula for that. You can also take the model name. Then I'm giving the color for the line, that is red, and line width I am taking as 1. You can change the line width, and I'm executing this command. So you can see there is a straight line, which shows there is a very positive linear relationship between height and weight in the data set that we got here. Next, what we are doing is, we are predicting the value of weight with a new data set of height. So let's first check the values of our women data set. What I'm doing is, I'm taking the range of height and weight. So you can see in our data set, the range is from, for weight it is 115 to 164, and for height it is 58 and 72. The numbers are between this. So I'm creating a new data frame. I'm saving it in new data. The command to create a data frame is data.frame, and within brackets I am taking the vector, that is height equal to, so I am taking range that is not in this range that we already have. So I have taken 50, 75, 80 and 85. Now let's execute this command. If you want to check what we have saved in this data, you can see I have 4 variables here. Now what I am doing is, I am giving the command predict in order to predict the values of weight with my new data. I am saving it in predict underscore weight, predict function within brackets, same model that we have created, comma, the new data that I have got just created right now. So let's execute this command and check the value of predict. So you can see for 1, that was when my height was 50, the weight that I predicted is 84.98. Similarly, when it was 75, my weight is in 171. So you can see there is a linear relationship again. As my height increases, weight is also increasing. Now let's build diagnostic plots to check the assumptions of linear regressions, and for that the command is plot within brackets name of the model. What it will do is, it will give you a series of graphs that will help you understand the assumptions. So to check the diagnostic plots, what we'll do is, we'll execute the command plot within the brackets name of the model. Now you can see there is a point here which is saying hit return to see next plot. So what we'll do is, we'll just click enter, and now there will be a graph here. So what we can see is the first plot, that is residual versus fitted, which is the residual plot. What it shows a relationship between x and y, and it should be a linear relationship. So there should be a straight or a particular line, and there should be no pattern there. So we can see here it is forming a proper line in order to show the linearity. We'll press enter again, and there will be our next graph, which is the normality graph or the QQ plot, which shows the quantile plot also. What it shows is, for fixed value of x and y, that is the variables here, so it is height and weight, data is normally distributed. And how we can test that, how we can see that our data is normally distributed, it should follow a straight line or a diagonal line. So we can see here there is a straight line here which shows the data is normally distributed. If there was any absence, or if there was the data is not in normal distribution, there will be a deviation in the line. Again, we'll be hitting enter, and the next graph is homoscedasticity graph, that is the scale location graph. What it shows is, it shows the variance of residuals in our data is in the same is the same for any of the value of x. So we have already seen this when we predicted the values also, that the data, that the residuals or the error that we have got, they are spread equally along the range of predictor. How we can see it is in a good, so how can we see that there is a equal spread along the range, is there should be either straight line or a particular line that should not deviate much, so that we know that our residuals are spread in a same manner. So we are again pressing enter, and our last graph is Cook's distance plot, which what it tells is the observations are independent of each other, and it also helps in identifying the more influencing values in our data. So we can see here there is a values 15, 14, which what actually means is the residual values of these observations, they influence our data much, and we should remove these values in order to make our model much more significant. But we can see there is a straight line also which tells the model is very much significant, and it helps in predicting our values of weight very significantly. So it was a very easy example of simple linear regression, and similarly we can predict the other models with other data sets also.